Okay, this video is going to show my solutions for the challenge worksheet for 11.1.4 for those of you who wanted a little bit of a challenge yesterday. In question number 1, we wanted you to find the volume and the surface area of this prism. Okay, and I know it's a prism because all of the lateral faces are rectangles and it has two congruent parallel bases, which are trapezoids. So this is a trapezoidal prism. The formula for the volume is area of the base times the height. And again, the base shape is a trapezoid. So to find the area of a trapezoid, I have to find the average of the bases times the height of just the trapezoid. So I know I use H and H here, but just be really careful. This is the height of the trapezoid, and this is the height of the entire prism. Okay, so just recognize that those are not necessarily going to be the same number. So area of the trapezoid, 20 plus 40 divided by 2 times 15. And the height of the whole prism, remember, even though it's on its side, this is not the height of the whole prism. The height is the distance between the two bases, which is 25. Plug that into your formula, you should get 11,250 units cubed. The surface area, 2 times the area of the base, so 2 trapezoids plus the perimeter times the height, perimeter of the trapezoid times the height. Okay, or you certainly could have added all the faces together if you wanted to. When I do the area formula for a trapezoid, remember there's a 1/2 in there, so 2 times 1/2 is really going to disappear. So I'm going to add the bases, 20 plus 40, get 60, times 15, I get 900. That represents the area of the front and the back, the two trapezoids. Perimeter, again, is of the trapezoid, so I do 20 plus 18 plus 40 plus 20. That's how I get 98 times the height of the prism, which is 25. Plug that all in, I get 3,350 units squared. For number 2, this was a good challenge because it had a lot of work and a lot of steps, and you have to keep it organized. Okay, now this is a pyramid. It's a pentagonal pyramid, and the base, the pentagon, is a regular pentagon. So we have to go back to what we learned earlier in the year on how do we find the area of a regular pentagon, because both formulas call for me to find capital B or the area of the base shape. So if you recall, I drew in this little triangle, okay, and I remembered that there would be 10 little triangles that made up the entire pentagon. So I redrew that triangle over here. I took half of 20 to get 10. A stands for the apothem, okay? And 36 degrees came from 360 total divided by 10 triangles to get 36. I used tangent to help me find the apothem, okay? And then remember, base times height, so 10 times apothem, 13.76 divided by 2, gives me the area of just one of the little triangles. However, there are 10 little triangles, so if I multiply this times 10, I get the area of the pentagon, the area of the base shape. So over here in both formulas, when I see a capital B, I plugged in 688.19. Okay, I'm going to talk about surface area first because it was a little bit easier in this problem. We did the hard part for surface area. It's the area of the base plus 1/2 perimeter of the base times the slant height, and we were given the slant height. So that was really easy. Perimeter of the base, if it's a regular pentagon, 5 sides, 20 each side, that's going to be a perimeter of 100. Plug that in, add it, I get 2,788.19 meters squared. Now, if you don't like using the formula, you certainly could find the area of the triangle because it's a regular pentagonal base. All 5 triangles are exactly the same area. So base of 20 times height of 42 divided by 2, and multiply that times 5 sides, and you should get 2,100. Okay? Now, the volume was a little more tricky because 1/3 area of the base times the height, the actual height. When you think about Mr. Kleinhenz's video, he gave you an actual height by putting the pen or pencil straight down the middle of the pyramid. Okay? And so what we have to do is use that idea and Pythagorean theorem to help us find the height. Now 42 is the slant height, that was given. This part here is going to be the apothem, okay? And again, the apothem came from our work over here. It's approximately 13.76, okay? And then I used Pythagorean theorem to get that the actual height was approximately 39.68 meters. And then I used that height for this. So 1/3 area of the base shape, which I found over here, actual height of the pyramid here. Plug it into my calculator, I get 9,102.63 meters cubed. If you got something close and your work matched up and you just had slightly different rounding errors, then you did fantastic. Okay? Last two. Number 3 was there for all of you algebra lovers. Okay? They gave us the surface area of a cylinder. So I wrote my formula out for surface area of a cylinder. They told me it was 603.2 meters squared, so I put that in instead of surface area. I substituted. I also substituted because they told me that it was 10 meters for the height. I put that in for h. And I made my r's red because that's what I'm looking for. I wanted it to stand out a little bit. Okay? So then the next thing I did was I simplified. 2 pi r squared can't be simplified. I just left that alone. But 2 pi r times 10, I can multiply the 2 and the 10 to get 20 pi r for my middle term. And my last term, I just moved the 603.2 to the other side. And again, the reason I did that is I saw it had an r squared and an r, and that's what I was trying to solve for. So I want to turn it into a more familiar looking standard form quadratic equation, because then I can use the quadratic formula. Remember, the quadratic formula is the opposite of b, everything except r, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. And that looks like a big mess, and I didn't bother doing pieces and parts at a time. So I just plugged it all into my calculator at once. Now, technically, the plus and minus are going to give me 2 separate answers, but remember I'm talking about the radius of a figure. So if I have a negative number plus something, oh, that might be negative or positive. If I have a negative number minus something, it's for sure going to be negative, and that's not going to be the answer I'm looking for a radius. A radius cannot be a negative number. So I plugged into my calculator all at once using the fraction button, using the pi button, using parentheses. And I got approximately 6.000102 something, something, something. What that tells me is it's really, really, really close to 6. So I'm going to say that the radius in the problem, which is what we were asked to find, is 6 meters. And then I wanted to check my answer to see if it was reasonable. So I took the 6 and I plugged it in for r here, and I plugged my 10 in for h. And my answer became 603 point, I think it was 18. So it certainly rounded to that answer. Okay? The very last one. This one was talking about a cone, and it said the given information was that the area of the base circle was 64 pi inches squared, and that the volume of the entire cone was 320 pi units cubed. So I started by writing out my formula for volume of a cone, remembering that the pi r squared really represents the area of that base shape, okay, which is what we were given here. So 1/3, I put the 320 pi in for v, I substituted. I put the area of the base shape, pi r squared, here in for pi r squared. And then I started to solve for h. So I multiplied both sides by 3. I divided by pi in my head. I knew that was on both sides, so it's gone. 960 divided by 64 is 15. So now I knew the height, so I drew it into my picture that the height was 15. Then I used the idea that the area is pi r squared of a circle, and I know it's 64 pi, so 64 pi equals pi r squared. I divide both sides by pi, 64 equals r squared. Now technically r could be plus or minus 8, but again, because I'm talking about a figure, -8 doesn't make sense, okay? 8 makes sense. 8's the radius here. So I added that to my figure. Finally, I know that the surface area, which is what the question was asking for, is pi r squared plus pi rl. So I have the radius as 8. I have to find the slant height, and of course by now you guys know Pythagorean theorem, and you will get 17 for the slant height. Plug that in, you get exactly 200 pi. And since both of these in the given information were in terms of pi, I left my answer in terms of pi as well. Okay? If you guys have any questions, shoot me an email or sign up for a Google Meet.